Don't you watch when you're going, you old goat?
I'm sorry, Uncle Darko. I tripped over you. I'm gonna fall. Oh.
In the hell you doing?
Oh. Oh, what the hell have you done to me, Uncle Darko? Hey, Uncle Darko. Hey. I didn't see you there. I tripped over you again. I can't get up. I've fallen and I can't get up. How about you? Good afternoon, everybody, and welcome to the Blind Tinkerer's shop again. Before I show you what I'm up to, it is now 3 o'clock in the afternoon here, and this is the Blind Tinkerer, and I got another project going on here that is really, I shouldn't even be buying stuff because I'm always broke all the time. My price range is usually $20 to $30 on eBay. Before I show you what I got on the bench here, I was looking last week on eBay for some, I don't know, just scouting around for stuff to build this, and I've already got that on order now. It's a tablet holder with a 26 or 27 inch flex tube. So I'm all set there, just waiting for that to come in, and then I'll put a piece of conduit across the top here so I can slide it on back and forth on that, or I might even use a small piece of wood. Not sure yet. Things change on a hourly basis around here. Now, one of the reasons why I'm always broke is because I always see something on eBay that I could use in my shop. And this particular item that I'm going to be showing you here very, very shortly here, keep you in suspense a little bit longer anyways, is something I really probably don't need, but it looked neat. It was on eBay for $20 or best offer. Not working. $15 shipping. So I put a best offer in of $10. He came back with a counter offer of $15. So it cost me $30 for this, counting the shipping. So this is why I'm broke this week, folks. You ready for what I got on the bench here? I've already unpacked it and started looking into it, so there's not an unboxing video. Here we go. Here I've got a Motorola S1052B DC voltmeter. Don't ask me why I picked it up. I just thought it looked pretty damn neat. Now, what I found wrong right off the bat is this is a C-size battery. It's 1.2 volts, 2500 milliampere hours. This is stone dead. Contact was corroded here. Oh, I didn't have anything like that, so I got a 1.5 volt alkaline in here. And right now this is set for ohms, and it works. It was as is for parts not working. But it's a little erratic. I don't like these clips at all. They don't open wide enough. And they're not making good contact. There they go. This reads very low in ohmage. This will read down very, very, very low. this also came with an RF probe. Right here. Which takes a mini, I call it a mini B&C. It looks like a B&C, only it's much smaller. It won't fit the standard B&C. It's very, very small. It fits right here. And in fact, it takes very small fingers to get in there to give it the twist. And she fits in like that. It's an RF probe. But unfortunately, I have no book on this. Book is impossible to get. There's another one of these on eBay for $89 plus shipping, not working for parts only. So I thought I got a damn good deal on this. Let me show you what was done in here. I'll be glad when I get my shop camera set up. I don't have to work like this. Somebody had installed, as a matter of fact, the guy, I had good communication when I put two 9-volt batteries in here. It takes an oddball Burgess battery, which is no longer made, 22.5 volts. A 4156. Is the battery. This came with two 9-volt batteries with the battery connectors on them and everything. So somebody did a mod on this. And over here there's a bag, plastic bag, that the Burgess battery would normally go in, and then the connectors went up on top. There's a diagram here, but it's all discolored. It's very, very hard to read. And I took a close-up on my digital camera, and it is a 4156 22.5 volt battery. So they got two 9-volt batteries in series. So you've got about 18 volts. Fresh batteries would probably be almost 10 volts apiece, so you got 20 volts. So, all right. Right now she's on ohms. This is the amp position. This is the ohms. This is the volt position. The meter is slow acting. And it goes off scale, and you have to keep on. It don't respond instantly to the zero adjustment. See how she goes? So I'm not sure what it is. It'd be nice if I had a service manual on it. It does go to zero, but it's a delayed action. Okay, and this is the RF volts. Again, you have to play around with the zero adjustment. It seems to work pretty good on ohms. And this is the B plus check. Now, the meter is anywhere from the OK to the right is good. And that's the test of the 22.5 volt battery. So even though we only got 18 volts or two 9 volts in series, according to this, the B plus is good. That's what they call the B plus over here. I don't know if you can actually see that or not. All right. There's right here is the B plus, and if you're looking at the meter, it's right on the top scale here. All right. Now, here's the resistance ranges here. R times 1 all the way up to R times 100,000. I can't quite read that with my bad eyesight. This is only a DC multimeter. When I bought this, I didn't pay enough attention. Not that it would have mattered. I probably would have got it anyways. It's only DC. Now, do I need it? No. Would it look nice on my bench? Yes. Was the price right? Yes. So I got it. Now let me show you inside here. And I'm going to turn this off here. And I'm going to unhook the wires here. Well, I can't unhook these wires over here, but I can take the RF probe out. Okay. It's pretty neat. Usually you don't find instruments with the RF probe. This is a Motorola RF probe. Model SLN6055A. That's the Motorola part number for this. Frequency range 1 kc to 400 megacycles. Right here. Doubt you'll be able to see that. Maximum DC voltage 400. Maximum AC voltage 10 volts. Motorola Incorporated, Chicago, Illinois. It says here to be used with the DC multimeters models S1052B and the S1063A. This is the 1052B. Alright, let's see if I can get you in. I've got the camera sitting on the case of this meter here. This is made really well. Nobody has gotten in here that I can tell and messed it up, other than the battery compartment, which I'll show you a close-up of that. Over here is 1.5 volt C-cell alkaline that I put in to replace this dead NiCad. I'm sure it's a NiCad. This instrument was manufactured in 1966. I didn't think that I knew they had transistors then, of course, because I was working with transistors. So I know that transistors were, transistors came out, I believe, in the late 40s. Anyways, so there's no vacuum tubes in this. It's made really, really well. And circuit board and everything, it's got these Motorola transistors up on top. They look like top hat type transistors. I remember those in my experimentation days. Your resistors have got like a varnish coating on them, and the capacitors look like they're really made very good quality. The brown ones there, they're shiny. They look like Mylar. And the power supply is right here, the wire, but there's no plugs here that I can remove. There's your calibration controls here, and the capacitors seem to be a sealed, a good type of capacitor. The instability could be that the switches need cleaning. That's probably what the problem is. And here I am buying stuff, and I still haven't bought the contact cleaner yet. I need to go and get that in person. Anyways, let me show you the other end here, the power supply. Alright, here is where the Burgess battery would normally go in. And like I say, they put in this bolts in like this. This bracket screws into this right here. So these are not original. The guy I got this from said he put batteries in it and it did nothing. When I got it on the bench, I reached around the back, and I'll show you in a minute here. There's a 110 volt switch right here. Let me get the screwdriver, get my hands in the way here. There's a switch here that switches over from battery to line. And the switch was halfway between, so he might not have pushed the switch all the way up in battery. When I pushed it up into battery, this thing started working. I was very concerned with the meter movement. I had wrote him. He answered me promptly, and I asked him, is the meter movement good? That was my biggest concern. If the meter movement's no good, it's basically junk. The meter is made by Simpson in this particular instrument. And he says, I don't know. I put new batteries in it and nothing. Here we go. Here we go with the phone again. Hello? Okay, that was my wife. We don't have I don't have an intercom system set up here in the workshop. So I gotta take my son to the bank to cash his paycheck, so I have to drop the video right now. But what I want to do is I'm going to end this video very soon here, but I want to show you the back of this unit, because I not only have a question as to the batteries, but I think it's fine with 2 9-volts in there. I'm making this video, who knows, maybe some of you guys might even have this instrument. I would like to get the user's manual on it, because I don't understand all the features of how to use it. Alright, now let me go show you in the back here. Before I do, and I'm holding the camera very steady, you can see how nice this is made. This is made really, really nice. Good precision instrument. There is a place on the internet, I think it's in German, I'm not sure, that has some nice photos of a unit just like this, except it did not have the photos for the battery compartment. And that guy had a 1.5-volt alkaline put in here, in this spot. But his pictures didn't show this. This was not on eBay, the one I'm talking about, the German, I think it's German, or Russian, one of those. I couldn't really tell. But it didn't show this area, so I think all this was missing. Before I show you the back, you look down here, there is a power supply here, okay? So there's rectifiers, there's top hat rectifiers. You remember the top hats? I do. On the back here, see that battery and line switch, okay? The switch was halfway. It wasn't all the way up to battery, so that might be why it didn't work. But my question is, what voltage goes in here? There's 3 pins. That don't look like a 120-volt outlet, and I wouldn't, a receptacle. I wouldn't dare put 120 volts in here. That's one of the reasons why I want to get the manual on this. But that's the only jack on this. This is pretty neat too. It's got spring-loaded screws. You push them down and give them a turn, and they hold in to these little grabbers that are right here. So this is a commercial unit, Motorola, and I like the finish, the crinkle finish on it. So it was such a nice-looking piece of equipment, I had to get it. Anybody out there know where I can get a manual on this? Basically to how to use it. There's some features on here I'm not really sure of. And one of the most important things is, what voltage does this thing take from the line? It's a simple little power supply, no transformer. That's the switch right there. You're looking at the power supply. There's 3 wires here that go to the unit, and I tried pulling them out, and I think they're soldered in with heat shrink. I don't know, did they have heat shrink in 1966? It's a good question. But you can see this, see the back side of this jack here? I think you can see that. I'm being held back by the bracket on the meter here. See that? It's thin wires. The jack is loose. I got to tighten it up somehow. It don't appear to be a 120-volt jack. There might be a special transformer that goes in here. So I'm sure that's not 120 volts. All it's got is a couple of electrolytics and top hat rectifiers. You can see them right here, and very thin wires. So I don't have any problem with running this on battery. Not at all. Not at all. But there's some features I don't understand about it. Like your plus ohms, your balance, and then down here you've got a jack for balance. See that right there? So I really would like to get a manual on this, and I can't find nothing on the internet. So here it is, everybody. Motorola S1052B DC multimeter. Another toy for the tinkerer's workshop. Thanks for watching.